A 3I minus 2J plus 3K Tesla magnetic field vector passes through a current-carrying wire coil that has 12 turns and a 4I minus 5J plus 2K meter squared area vector. A current of 2 amps flows through the wire. What is the vector torque experienced by the coil? Okay, so whenever you're given a problem that asks for vector torque, you want to write down the formula for vector torque. And the formula is vector torque is equal to N, which is the number of turns, times I, which is the current, multiplied by the cross product of the area vector and the magnetic field vector. So I'm going to rewrite it over here. T is vector torque. N is the number of turns. I is the current. A is the area vector. And B is the magnetic field vector. Okay, now, looking at the problem and the equation, let's see what the problem gives us. It says that a 3I minus 2J plus 3K magnetic field vector passes through a current-carrying wire coil that has 12 turns. Okay, so N is 12. And a 4I minus 5J plus 2K area vector, a current of 2 amps. So our current is 2. And that's it, pretty much. We have to find the cross product between A and B. But we know that they give us the IJK notation of both A and B. So let's find what A is. Okay, so 3I minus 2J plus 3K. This is for the magnetic field vector. This is not A. 4I minus 5J plus 2K. Okay, this is for the area vector. So we write down 4I minus 5J plus 2K for the area. And okay, this one is the magnetic. So 3I minus 2J plus 3K. This is for magnetic field vector. Once we have this, we can find the cross product of those. So write down your I, your J, K, set it up. A will be in the first level, B will be in the second level. So our A component for our I component for A is 4. J for A is -5 and K is 2. For B vector, our I is 3, our J is -2, and our K is 3. So once you have that, you can find the components of the cross product of this. So to find I, cover up the I, multiply -5 by 3. You have -5 times 3 is -15. Minus -2 times 2 is -4. This will be your I. Once you have your I component, always put negative before you start your J. Cover up the J to find your J. 4 times 3 is 12. Minus 3 times 2 is 6. This will be your J. Once you're done with the J, always add a positive for the K. Cover up the K. 4 times -2 is -8. Minus 3 times -5 is -15. This will be your K. So our cross product between A and B is going to be equal -5 minus -15 minus -4. -15 minus -4 gives you -11 I. 12 minus 6 is 6. So keep some negative here. 6J. -8 minus -15 is 7. So keep the positive. 7K. So this is going to be your cross product for A cross B. So you can write it here. So -11 minus 6J plus 7K. All right, and now that you have these, you just have to find the vector torque. So before we begin finding the vector torque, let me erase this to provide us with more space. Okay, so we have our torque. Vector torque is going to be equal to 12 times 2, all that multiplied by -11 Don't forget the I minus 6j plus 7k. 12 times 2 is 24, so you could just do 24. And then multiply that. Okay? Okay, now whip out your calculator. 24 times 11 times negative 11 is negative 264. So it will be negative 264i. 24 times negative 6 is going to be negative 144 minus 144j. 24 times 7 is going to be 168, so plus 168k. So this is going to be your vector. Units will be in newtons, and there you have it, your answer.